Hi, in this video we are going to talk about the concrete implementation of the Towers of Hanoi problem, and I think it's quite counterintuitive because it seems a very complex problem, and we can come to the conclusion that we can formalize it with the help of this very short method. Of course, I'm going to instantiate the algorithm. I would like to solve the problem when I have the first rod, second rod, and the last rod, the A, B, and C, and I have 3 plates. If this is the int n, the number of plates, the rod from, the middle rod or the auxiliary rod, and the rod to. So we want to get the plates from the rod from and want to place it to the rod to. This is the base case. If the n is equal to 1, so we have a single plate left, we are going to print it out that the plate 1 from the rod from to the rod to, because we are able to do it, and just return. And anyways, we will have 2 recursive method calls as we have discussed in the theoretical section. First, because we want to put n-1 plate from the rod from to the middle rod with the help of the rod to. And if we do it, we are able to shift the last plate, which is the biggest, we are able to shift it from the rod from to the rod to, as we have discussed. And then we just have to call the method recursively for the n-1 rod. But it's very important that we want to get from the middle rod to the rod to with the help of the rod from. So it's very important to see the difference. In the first section, we try to move from the rod from to the middle rod with the help of the rod to. Here, because we know that the greatest plate is on its right place, the rod to, then we want to get the plates from the middle rod, and with the help of the rod from, we try to place it to rod to. So these are the subproblems. And it's working fine, as we can see. Yeah, it's working fine. So that's all about the implementation. Thanks for watching.